Now today in this lecture we are going to see how to solve a PERT problem. The difference between PERT and CPM is that in CPM for every activity there is only a single time estimate, whereas in PERT for each activity there are 3 time estimates are given. They are called optimistic time, pessimistic time and most likely time. The relationship between them, optimistic is represented by small a, most likely by small m and pessimistic by small b. The relationship between them is that optimistic is the shortest possible time, most likely time is greater than optimistic time, but it is less than pessimistic time. So optimistic time is the shortest possible time for an activity, and pessimistic time is the longest time required by the activity to get completed. So from this data we have to draw the network diagram, but before network diagram we need to convert these 3 time estimates into a single time estimate, that is called expected time of the activity. So the question is, the data is given to us, activities are given and their node relationship is also given, and the 3 time estimates of each activity are given, and the question is we are supposed to draw a PERT network diagram and then find the expected project completion time, variance and standard deviation. Variance and standard deviation we will see afterwards. First we will see how to calculate the expected time. So when we start the solution, the step 1 is preparation of this table, in which we will calculate the 3 values for every activity. First value is the expected time of activity, and the formula for expected time is TE is equal to A plus 4 times M plus B divided by 6, means optimistic time plus 4 times most likely value. So this value of M will be multiplied by 4 plus the pessimistic value and divided by 6. So for example, for activity A, the optimistic time is 4 plus most likely time is 6. So 6 into 4 is 24 plus the pessimistic time is 8. So plus 8 divided by 6. So 24 plus 8 is 32, 32 plus 4 is 36, 36 by 6 is 6. So the T value will be 6. Next, for activity B, A is 5, M value is 7, so 7 into 4 is 28, plus B value is 15, so plus 15 divided by 6. So this total is 28 plus 5 is 33 plus 15, 48, 48 by 6 is 8. Okay. Now you can use the shortcut for calculation of these values. If you observe the 3 values, now see for activity C, 4, 8 and 12, check the interval between the values. If the interval between A and M and the interval between M and B is same, now see here 8 and 4 the interval is 4, and 8 and 12 the interval is also 4. So the interval is same, then in that case the T value is directly equal to the M value. So we can here directly write the T value as 8. Next, here also 10 to 18 interval is 8, and here also 18 to 26 interval is 8. So our T value will be 18. So this is 18. Where the interval is not same, we have to calculate. So here 8 and 9 and 9 and 16. So the interval is not same, so we have to calculate. So for E, it will be 8 plus 9 into 4, 36 plus 16 divided by 6. So that is 36 plus 16 is 52, 52 and 8 is 60, 60 by 6 is 10. Now here the intervals are same, 4, 8, 12, so T is the central value. So for F, T will be 8. For G, 1 to 2, interval is 1, here also interval is 1, so it is same. So T value will be 2. H, 6 to 7 is 1, 7 to 8 is 1, so T value will be 7. So here also T value is 7. And then we calculate the standard deviation variance. This we can do later on also, but okay, we will continue with this so that the table is completed. Now B minus A by 6, so the B is the pessimistic value and A is the optimistic value. So pessimistic minus optimistic divided by 6. So the first is 8 minus 4. 8 minus 4 divided by 6, that is 4 by 6. Second value will be 15 minus 5, so 10 by 6. Third is 12 minus 4, so 8 by 6. D is 26 minus 10, so 16 by 6. E is 16 minus 8, so 8 by 6. F is 12 minus 4, so 8 by 6. G is 3 minus 1, so 2 by 6. And H is 8 minus 6, so 2 by 6. This is the standard deviation which is represented by sigma. The next is variance. Variance is the square of standard deviation or sigma square, and it is represented by V. So we square the values. So these are the squares. These are the squares of the sigma values, that is the variance. So now we have the TE values, we have the SD value, and we have the variance value. Now we are ready to draw the network diagram, because network diagram we should draw with only TE values. So step number 2 is network diagram with TE values. Now the nodes of the networks are given. So activity A is 1, 2. So it's a node kind of network. Nodal relationship is there. So activity A is 1, 2. Then B is 2, 3. So 2, 3. This is B. B is 2, 3. Then C is 2, 4. So 2, 2, 4. So this will be C. C is 2, 4. Then D is 3, 5. This is D. D is 3, 5. Then E is 4, 6. E is 4, 6. Then F is 5, 7. And G is 6, 7. So this is G 6, 7. And H is 7, 8. Okay, just cross check the network. A is 1, 2. Then B is 2, 3. C is 2, 4. D is 3, 5. E is 4, 6. F is 5, 7. G is 6, 7. And H is 7, 8. Now we will write the TE values in this. In the network diagram, we will write the TE values. Okay, now that we will not refer the pessimistic or optimistic values, only TE values. So A, TE value is 6, B is 8, C is 8, D is 18, E is 10, F is 8, okay, this is F, F is 8, then G is 2, and H is 7. Okay, 6, 8, 8, 6, 8, 8, D is 18, E is 10, F is 8, G is 2, and H is 7. Okay, so now our network diagram with TE values is complete. Now we will see the paths in the network, because we want to find a critical path. So the first path is from above, that is A, B, D, F, H. The total time value is 6. 8 plus 6 is 14. 18 plus 14, 32. 32 and 8 is 40. 40 and 7 is 47. So the first path is of 47 days. Second path is from below, that is ACE, GH. Calculate total time. 8 plus 6 is 14, 14 and 10 is 24, 24 and 2 is 26, 26 and 7 is 33 days. So our critical path is 47 days. This is the longest path. So this is the critical path. Now we will highlight the critical path in the network, that is A to B, D, DF, and then H. So A, B, D, F, H. A, B, D, F, H is our critical path. And now we can say that the expected project completion time is 47 days. Okay, now we need to calculate the variance of the project and the SD of the project. Now we have calculated the expected project completion time. Now for calculating the variance and SD of the project, now you should consider only the critical activities, which is A, B, D, F and H. So our critical activities are A, B, D, F, H. A, B, D, F, H. So we will calculate only for these activities. So consider only these values. Okay, so now we will calculate the first variance and then the SD. So you should remember that when we are doing calculation for the critical path for variance and standard deviation, first calculation is always for variance and second calculation will be for standard deviation. So we will calculate it here. So this was answer number 1, the critical path. Next is variance of the project. Now variance of project is summation of critical path. Summation of critical path variance. So we will add all the values here. We can call it V star. Variance of the project, we will call it V star. So V star values are 16 plus 100. The numerator for all the values is 36. The denominator for all the values is 36. Okay, so we will add the numerator and denominator is common as 36. So 16, then 100, then 256, then 64 and 4 divided by 36. Okay, so the total of this variance of the project, you add the all numerator values and you will get the numerator as 440. So it is 440 by 36 and the value will be 12.22. So the variance value, variance of the project or V star you can say is 12.22. Now we have seen here that variance is square of sigma. So now when we want to find sigma, we will take square root of variance. So we will say therefore sigma is square root of V star, that is equal to square root of 12.22 and you will get it as approximately 3.5. So the value of sigma is now 3.5. Now this completes the first part of our solution. In this what we have done is, first we have converted the three values, optimistic, most likely and pessimistic, we have converted in TE values using this formula, that is step number 1. Then we have calculated sigma and variance for each activity by using the respective formula. After that we have drawn the network diagram using the TE values. Okay. So this is very important, you should remember that when you draw network diagram, use only the TE values. Then you find the paths and you find the critical path and then the longest path, that is critical, and then we get the expected project completion time. After that we calculate the variance of the project, that is sigma, summation of all critical path variance. So we select only the critical path activities and we add their values and then we get the V star. And then after that we take a square root of that variance or V star and you get the sigma or standard deviation of the project. This completes the first part of the solution. Okay, so now we are going to continue with the second part of the question, which is related with probability. So there are certain probability questions related to Pert. How to answer those questions? So before we go to probability questions, first understand the normal probability table or that curve. This is called a probability distribution curve. It's a symmetrical curve, a bell-shaped curve, and the assumption here is it has been proved that the center line of the curve corresponds with critical path. This total area of the curve is 100% and it is equally distributed on both sides, 50% and 50%, or you can say 0.5 and 0.5. The total p value, total probability value is 100%, or in decimal it is 1.00. So the center line of the curve divides the curve in two equal parts, 0.5 and 0.5, and the critical path is at the center line. So if we start the probability calculation or the time calculation from here, when we reach the critical path, how much we are covering area? We are covering the area of 50%. Okay, so when we reach the critical path value, we are covering 50% of 0.5 of the area of the curve. Therefore, we say that probability of critical path CP is always 0.5 in any question. So now, if we go beyond the critical path, so if the time is greater than critical path, obviously the probability value will increase because we are crossing the 50% line. So if the time is greater than critical path, then the p value will be greater than 0.5. Similarly, if the time is less than critical path, if the completion time of project is less than critical path, so if we are on the left side of the curve, then the area will be less than 0.5. So p will decrease, probability will decrease, and the p value will be less than 0.5. So this much we should understand before we start the probability calculation. Okay, so I repeat, probability of critical path is always 0.5 or 50%. If time is greater than critical path, probability will be greater than 0.5, that is greater than 50%. And if the time is less than critical path, probability will be less than 0.5 because we will be on the left hand side. So probability will be less than 0.5, that is less than 50%. Okay, so this you should always remember before you start solving the probability questions. Okay, now we will actually start solving the questions. So the first question is find probability of project completion in 50 days. Okay, so we will start with B. Now the time given, T value is 50 days. Now for all probability questions, we use the Z formula, that is Z is equal to T minus critical path divided by standard deviation. This is the standard formula we use for all probability based questions. So now we will calculate Z value. So Z is equal to time is 50, critical path was 47 days, and ACT was 3.5. So when you solve this, you will get Z value equal to 0.86. Okay. Now we use this table. This is called a normal probability table that is provided in the question. We will use this table for finding the probability. Okay. So now when we refer this table, how to read the table? Now see, Z value is 0.86. If you see the first column of the table, it is Z. So 0.86, so you come to 0.8, so this is 0.8, you come here in 0.8, and the second decimal is 6, so now refer the column of 6, so 0.86, so here we get 0.86, so the value here you will get is 0.3051, so the area is 0.3051, you see 0.8 and this is 0, 1, 2, 3, 4, 5 and 6. So 0.3051. This is the area under the curve. Now we have already said that if time is greater than critical path, probability will increase. So by how much it will increase? It will increase by this much. So therefore we can say P of 50 days is the original probability was of critical path was 0.5 and this is the increase. So 0.5 plus 0.3051, so that is equal to 0.8051. If you multiply by 100, you will get in percentage, so that will be 80.51%. So this is the answer of the first question. Okay, now we will go to next question, that is C. Find probability of not completing the project in 45 days. So now the question is about not completing the project, but first we will find the probability of completing the project. So now time given, T is equal to now 45 days, Z T minus critical path divided by ACT. So time is 45 days, critical path is 47 days and SD is 3.5. So therefore when we solve this, we will get Z equal to minus 0.57. Now we are getting a minus sign because time is less than critical path. Okay, and we have seen that if the time is less than critical path, probability will be less than 50%. So there will be a subtraction, and that subtraction, that is why the minus sign is coming. Now, referring the table, Z is 0.57. So we go to the column of 0.5. This is column here 0.5. You can see here 0.5 and 0.57. So row number 0.5 and column number 7. So in 0.5, 0, 1, 2, 3, 4, 5, 6, 7. So here the Z value is 0.2157. Okay, the area value. So area corresponding with this Z of 0.57 is, you can say, 0.2157. So area is 0.2157. But the sign has to be now negative because the Z is negative. So there will be a subtraction. So we say, therefore, P of 45 days, original probability of critical path is 0.5, and now this Z is minus, so area is minus. So we will now subtract this. So 0.5 minus 0.2157. So it will be 0.2843, or in percentage terms it will be 28.43%. But now this is probability of completion. This is P of completion. Whereas what we want is P of non-completion. Probability of non-completion. Total probability is always 1 or 1.0. So probability of completion and probability of non-completion, summation will be 1. So therefore we can say P of non-completion is equal to 1.0 minus P of completion. So this value, when we subtract from 1, we will get probability of non-completion. So that is equal to 1.00 minus 0.2843. So that will be equal to 0.7157, or if you multiply by 100, that is 71.57%. So this is the P of non-completion of project in 45 days. Now we find the answer to the question number D. Now if you see the question here, in the first two questions B and C, the time value was given 50 days and 45 days. Here in question number D, time is not given. We have to find the time. Okay, find the project completion time, and what is given to us is the probability value. 90% confidence level means 90% probability. So the P value is given to us. So P is 90%. So that is 90 divided by 100. So we can say P is 0.9. Now this P is 0.9 is given to us. Now we have to go in a reverse way. So first we have to find the area of the table, and then we will get the Z value. So now we are going in reverse. See, in the first question, time was given. From time we found the Z value. From Z value we found the area in the table, and from the area we find the probability. In this question, probability is given to us. Now from here we will find the area in the table. From area we will find Z, and from Z we will find time. So we are going in the reverse direction. Now P is 0.9. So from this, first find the area. So from 0.9 you subtract the original value of 0.5, that is the probability of critical path. So what remains is 0.4. So the A value is 0.4. Now you should not look in the Z column. This is the area. So you should be looking in the table. So we will look for area of 0.4 in the table. Now when you search the table, you won't get 0.4 exact value, or you won't get 0.400. You will get an approximate value. So search the table for a very nearest value, and when we search for 0.4, we see this first value of 0.4, that is 0.4015. This value we will get here. So you can say it is the nearest value. So the nearest value is 0.4015. Okay, that is in the line of 1.2, the last value of 0.4015. And now we will get from this area, we will get the Z value. So for this 0.4015, you see it is in the line of 1.2. So our Z is 1.2, and the column number for 0.4015 is 9. So our Z value is 1.29. So this is how we get the Z value in the reverse way. Now we can use the Z formula. That is Z is equal to T minus critical path divided by SD. So now when we simplify this, so Z is 1.29, time we have to find out, minus critical path is 47 days and SD was 3.5. So when we simplify this, so 1.29 into 3.5 plus this 47 will come on this side plus 47, that is equal to time. So now when we simplify this, the time we will come to know is 51.5 days. So the time, completion time corresponding with 90% confidence level is 51.5 days. So this is how we solve that reverse question where the probability is given to us and we have to find the time value.